Now, one of the things I said last week on this step-by-step packet, okay, and this is what I'm going to be looking for when I go through these, is the last one said calculator allowed. So therefore, the other ones are no calculator. Okay, so I want to see. So we need to see some work if there's places you need work. Now, in this particular one, it was all graph. Now, you're going to need the reason, justify your answer, stuff like that. Okay, but this is some stuff we haven't spent a lot of time on lately, the chart kind of things, max, min, concave up, concave down, that kind of thing. Which one, and I'm assuming it might be one of these no calculator ones, would be probably what I would suggest. Now, I think, to be honest, this one, it seems like this one, in some years I've said, maybe you should use your calculator for this one. Some parts of this would get a little bit ugly. So let's talk about this. And then if you want to see another one here with the no calculator and the algebra that you need to do, we can do that. Any part of this one? The Angry Birds one? No? Okay. How about 31, 32? Any issues with that at all? On part C, where it says write an expression for the absolute minimum value, that should be the output. It should have a K in it. No? Easy? What do you got on your number line here for part B? Don't you have a number line on part B for 31? Okay, let's talk about it. You have questions on something you don't know, but if you don't know that you don't know it. And yeah, that's what I'm saying. That's the worst part, or the tough part is when you don't know what you don't know, right? And so, yeah, let's talk about this one. So, first of all, in this part, you know, and this is very typical of a free response kind of question, where they know you need to use f prime later in the problem, and they're afraid you're going to mess it up. So they say, just show that this is f prime, and so if you do mess it up, the smart thing is use their f prime, not yours, maybe, right, when you get to that point. But they do want to see your algebra and see your work for doing this, okay? So if I do the derivative here, bring down the 1/3, I get 4/3 x to the negative 2/3, okay? Minus, and I bring down 4/3 here, I get 4/3 x to the 1/3, and derivative of a constant is just 0. So there's your derivative. But now you got to show that this is the same as that. Okay, so what would you do? What did you do to do that? Do what? So you take almost like a T-chart. So instead of rearranging this, rearrange this one. That's a smart move. So you get 4 over 3x to the 2/3, and you get 4x over 3x to the 2/3. That's not a bad idea. Okay, now. This I could bring up, and this would be 4/3 x to the negative 2/3, and this one I could subtract these powers. 1 take away 2/3 is 1/3, and so this becomes 4/3 x to the 1/3, and that would work for your show. Okay, now, the bad news. Oftentimes, you don't get to do that. They don't tell you the derivative, and then you have to work the problem. So let's pretend for a minute they didn't give me this. Okay? Let's pretend they didn't give us this f prime. For what values is f increasing? So, again, let's get back into our derivative mode here a little bit. And they asked me, where is f increasing? What are you thinking you need to do? Number line, do the derivative, set it equal to 0, right? Do the derivative, set it equal to 0. So let's pretend we don't have this. They asked me this. So it's no calculator, so I do the derivative and I get to here, right? And I get right to here, and I want to set that equal to 0. How in the world do I do that algebraically? What would you do? Exactly. What you'd want to do is get it like this, right? Because where is this 0? When the top is 0. But now, the part you guys were missing was we also have to consider where's the derivative undefined, because a sharp point could be a change from decreasing to increasing also. Okay? You have to consider critical points, which is where the derivative is 0 or where the derivative is undefined. Okay, but we're not ready for that yet. How do we solve something like this with these fractions? Well, let me give you a hint. If I gave you this problem, I think you would all know what to do. What would you do to solve this? You'd factor out a 3 and an x, x to the first, x to the second. Why did you factor out an x to the first? Why not factor out x to the second? Because the second one doesn't have 2 x's, right? You factor out the smallest number of x's that there are. Okay, so now I'll ask again. What can we do on this one right here? Factor out a 4/3 x to the negative 2/3. That is, factor out the fewest that are there. We've done this before. We haven't done it very often, but we have done it. Okay? So now, and this shows up. This often shows up in the no calculator part, either in a multiple choice or in a free response. Okay? So now, what are you left with right here? A 1, right? Minus, and then what are you left with here? Well, if you take out a 4/3, okay, that would be gone. What about here? Well, what happens if you have an x cubed and you take out an x? You got what? X squared left, right? You subtract the x's, okay, the powers. So if you had a 1/3 and you took out a negative 2/3, what do you got left? 1. It's always going to work that way because remember, whenever you do the derivative, you're dropping it by 1. So those powers are always going to differ by 1 when you get into these. Okay? So you're left with just an x to the first. Now, John, you had said, get it to look like this. Now, it doesn't quite look like that, although if we rearrange it here a little bit, if I drop this to the bottom, I would have a 4/3, 1 minus x, because up here you could pull out a 4, and you'd have 1 minus x, same thing. And then drop this x down to the bottom. And then likewise, I could, since this is 4/3, I could just have this 4 up on top with the 1 minus x, and then I can bring that 3 down to the bottom. So that would have been another way you could have shown that this derivative is equal to this. You could have just worked it that way. But I like what you did with the splitting up. To me, that was smarter. When you're trying to show that this is that, and you get here and you're like, God, I don't know what to do with that. So what you do is you work with this side, you rearrange it. But again, you may not always have that. And so if you're sitting here and you have to set this equal to 0, you're going to have to do some algebra here. Okay? All right. So we got to here. Now, what are our critical points? Well, we have a stationary point where x is 1. Clearly, the top is 0 when x is 1. But we also have to consider when the derivative is undefined, which is when the bottom is 0, which is when x is 0. Okay? And now, sometimes we don't have to worry about that because if the bottom is 0, if the derivative is undefined at 0, oftentimes the original is undefined at 0. And if the original is undefined at 0, you're not going to have an inflection point. You might have a vertical asymptote, though, and you might have a graph that is increasing and then switches to, it's increasing before and then switches to decreasing after, right? So it's increasing, then switches to decreasing. So you still would have to consider that. Now, if we were doing an inflection point, if this was a second derivative, where does the second derivative undefined, you might have a change in concavity. Now, in this case, we don't. We got concave up, concave down. But there's no point where that changes, right? If you had a graph like this, and you did a number line, if you did an F double prime number line on this, you would go from positive to negative. This switches from concave up to concave down. But is that an inflection point? No. You can't have an inflection point if there's no point. right? So you can't have a change in concavity in a graph and not have an inflection point if you have that situation. So this place where the derivative is undefined, where the function is undefined, we have to take that into consideration. All right, here's what your number line now should look like. We should have an f prime, we should have a 0, we should have a 1 on there, okay? And now let's say this is a 0.5, or no, negative, let's make that -1, that'd be smarter. Let's make this 1/2, let's make this 2, okay? Now, we're going to plug this back into our derivative. It doesn't matter, this version or our version over here. I wouldn't want to put it back up into this. Okay, but if I put a -1 into here, let's do that. So I put a -1 into the top up here, that would turn into a positive up here, 4 plus 4. If I put a -1 in here, what happens when you do -1 to the 2/3? Would that be negative or positive? Positive, because the bottom number is like the cube root, right? So you take -1 cube root it, that'll be negative, and then the 2 is like squaring, and that becomes positive. So you put a -1 in here, you're getting positive over positive, so this is going to be positive. Okay, but here's the part you would have missed out on. Okay, if you just put a 1 in there, I don't know what you guys tried when you put a 1 in there for your number line. What'd you try on this side? You couldn't try 0. What'd you try? -1. Probably. See, look what happens now when we put a 1/2 in here. When you put a 1/2 on the bottom, you're going to get, oh, we are still going to get positive, aren't we? Oh, you got away with it then, didn't you? Yeah, you got away with it. Okay? Now, you'd still lose some points for how you got there and for your work. But, yeah. But a lot of times that'll switch right there. A lot of times that'll switch. Okay? But you put a 1/2 in here, you're going to get positive. 1/2 down here, you're going to get positive. So it is okay. All right, and then you put a 2 in here, you're going to get negative, positive. Okay, so where's it increasing? So for what values of f of x is this increasing? So -∞ to 1. Now we don't have to leave out the 0, remember, because the graph is not undefined at 0. Right? The graph, the original function is not defined. If it would have been, we would have had to leave out the 0. You can't say the graph's increasing, where it's undefined. Yeah.
It could be negative within here, -8.
Probably -8, yes. That is an 8. It just didn't lay down. Yes, it would be -8. -8 to 1. Okay? All right. And then, so that's like a max. That's like a local max. And so, one of the things we talked about is our list of candidates, right, for an absolute minimum. So list of candidates would be a pretty good idea. So list of candidates for this one would be f of 0 and f of 1 and f of -8, where the derivative is, and then your endpoints, right? Remember how we did that? And then put those values into them. Okay? Now, the reason they said write an expression is because you're going to have a k in there. Okay? So that's why they said, they could have just said find the absolute minimum value, but then that usually denotes that it's an actual number. Show the analysis that leads to your answer. Now, lists of candidates would be like showing your analysis. Okay? Now, we could say it's increasing all the way from -8 to 1, and then it's decreasing from 1 to 8. So it can't be at 1. It can't really be at 0. So it makes sense that it's probably got to be at one of the endpoints. But so let's just put 0 into the original. What do we get? -k. Is that right? What do you get when you put? I can't scroll up there. What do you get when you put in a 1? What was the original function? Minus k. Okay, so we put a 1 in there, so we get 4 minus 1 minus k, so that'd be 3 minus k. Is that right? Okay, and then put -8 in there. Cube root of that's -2, so that'd be -8. Cube root of -8 would be -2 to the 4th, it'd be 16. And then minus k, so -24 minus k. And then put an 8 in there, that'd be 2 times 4, that'd be 8. Put an 8 in there, cube root is 2, that's 16, minus 16 minus k, so -8. So which one of those is the smallest? This one right here, right? because they've all got negative K in them, and then added onto it's a 3, a negative 24, and a negative 8. So the one with the negative 24 would be the minimum. So the answer they'd want would be this. This would be your expression. This would be your absolute minimum expression. All right. So anyway, I wanted to go back through some of that. This is going to be very similar, except it does talk about points of inflection, so you're going to have second derivative, right? We just haven't done some of those number line ones, and they're very, very common on the thing. So we're going to do some more of that as we get closer to the finals, because we just, we got to get those points. I mean, that's something we've spent a lot of time on. But we're going to start another big packet here tomorrow, so we can kind of get going on that. All right, let's go ahead and set that aside. Again, that and the 2017 thing we're going to hand in on Wednesday. Let's talk about your homework here. So we're kind of not our last day on volumes, but our last day on this volumes by the method of slicing. Now we're going to do an alternate form and another way we can do volumes, which can sometimes work better on some problems. Usually on the AP test, slicing is the way to go. Doing them by the method of slicing, adding up the slices is kind of the way to go. But this is another technique that is taught in most college classes, calc class. So I want to show that to you. We're going to do that on Wednesday. Okay. So here's the 5 different slices. So if you had, if you weren't here, we had these in the video. The two top ones are when you do a solid of revolution. So when you revolve a region, you're either going to get a circle slice or a washer slice, one or the other. Okay, it just depends if there's empty space in between where the axis is, the center. Okay, and then the other 3 at the bottom, those are all ones where it says, okay, here's a region, and that's the base of a solid, and then coming up off of the page is your solid. Okay, so the base of the solid is the region, and then coming up off of that, you have these different shapes, either squares or equilateral triangles or semicircle. Now, sometimes in the packets and on the AP test, they might do a different shape, but they give you enough information, you can figure that out. Okay? All right, so on your homework, let's just go through the answers real quick. So 13. So let me read these, and you see if there's any you want to look at. Okay, 13A, I got 8 pi. 13B, I got 128 pi over 5. 13C, now my answer book's mixed up. I think it was just mixed up with the pictures, though. Is C 256 pi over 15? And then D is 192 pi over 5. Okay, and I think in the answer book they have the pictures flipped. But okay, and on 15, we got A is 32 pi over 3, and B is 64 pi over 3. 22 is 368 pi over 3. That's kind of an interesting one. We can look at that if you want. 368 pi over 3 for 22. 25 is pi times ln4. If you use your calculator, it might have said 2 pi ln2, right? Because ln4 remembers ln2 squared, bring the 2 down in front. So your calculator might have said 2 pi ln4, or ln2. That's 25. 38 is 1/3 pi r squared h. Oh yeah, it makes a cone, is all 38 does. 39 is just a half circle, or a sphere, makes it not a half circle, it's half circle that rotates to make a sphere. And that comes out to 4/3 pi r cubed, which is kind of cool because it's just the area, volume of a sphere. But we can look at that if you need to. 49A is 128 pi over 3. B is 32 root 3 over 3. No, there's no pi on it. I'm sorry, 128 over 3. B is 32 root 3 over 3. And C is 16 pi over 3. 49. Okay, so 49. Now, they give you the picture, which I actually think is less helpful on those, to be honest with you. you know, trying to look at the picture and everything. So let's just read the directions on 49 and forget about their pictures. Find the volume of the solid whose base is bounded by the circle x squared plus y squared equals 4, with the indicated cross sections taken perpendicular to the x-axis. So if I was doing this problem, I would say, okay, that's bad. This is going to be a circle, radius 2, so hopefully we know that. X squared plus y squared equals 4, so that's our base. We're going to take our slices perpendicular to the x-axis, so that means one strip will be here like this. We got to do top minus bottom on that strip, so I need to solve this into this. Now, if this would have been, if it would have said cross sections taken perpendicular to the y-axis, then that means we would have had horizontal strips, okay? But now, coming up off the page, we have different shapes. So, maybe a square coming up off the page. Bigger squares in the middle, littler squares over here, right? Or maybe it's semicircles, or maybe it's whatever, coming up off of this base. And that's what the picture kind of shows you. Okay, so if we do part A, what was part A, a square?
Yes.
Part A is a square. Okay, so what is this strip? What part of the square that's coming up off the page is this strip? It's one side of the square, right? So this is, I'll just call that S. So that strip is one side of the square. So for part A, S would be the top y value, which would be root 4 minus x squared, minus the bottom y value, which would be negative root 4 minus x squared, right? So the top half of this is y equals root 4 minus x squared, and the bottom half is y equals negative root 4 minus x squared, like that. Okay, that's the key. Now, once you have that idea, now it's pretty easy, because now what you got is you got your strip is 2 root 4 minus x squared, right? So, what is our formula? Our formula is the area of a slice. If the slice is a square, the area of a square is what? S squared, right? S squared. So all we have to do is take this side, which is 2 square root 4 minus x squared. All we got to do is square that. And that goes from, strips would fill the space from -2 to 2. And then we type in it. Okay? Now, that's 128 over 3. So then, the next one is what? Equilateral triangles. Right? Okay? So now imagine a triangle coming up off of this page. Well, here it comes, right here, right? Here's a triangle coming up off that page. Equilateral triangle. What is this strip? It's the base, but they're all the same, right, on an equilateral triangle. So it's just, on an equilateral triangle, the base is just this one of the sides. And so here I put root 3 over 4b squared. I think the other day I put s squared on our notes. I think I had root 3 over 4 s squared. But it's the base, and that's what it is, because all these sides are b, right? They're all the same. So all we have to do is do root 3 over 4 on the outside. We do the same exact thing that's in here, and it's from -2 to 2. So really it's going to be that same answer with a root 3 over 4 multiplied by, right? And then the last one was semicircle. And so now a semicircle comes off this page, right? Here's a semicircle, bigger ones here, littler ones over here. What part of the semicircle is that strip? The diameter, right? So you got semicircle here. This strip is the diameter of that semicircle. So we came up with this formula the other day. It's really 1/2 pi r squared, but if you put 1/2 r in, or 1/2 d in place of r, it comes out to be 1/8 pi d squared, and that's what the strip is right there, is d. And here's your b, and here's your s, right? And so look what it is, it's a 1/8 pi. So C is going to be the same exact integral, except a pi over 8 out in front, and it's going to be 2, it's going to be the strip squared. 1/8 pi d squared from -2 to 2. So they're all very, very similar. Okay, makes sense? Again, the key is the strip. Key is the strip. You just have to picture that slice. Picture that slice and then say the strip is what piece of that slice. It's either one side of the square, it's one side of the triangle, or it's the diameter of the semicircle. And then you got it. And then this is area, and this is thickness, which of course goes to nothing, but area times thickness is what gives you volume, and then the integral adds it up. The integral adds it up. There we go. Adding up the slices. Okay, anything before 49? 13b, okay? 13b says, okay, it revolves, so we got square root of x, right? So y equals square root of x. It's revolving around this line right here, x equals 4, is that right? Is that what it's revolving? No. It's revolving around here, but it's bounded by x equals 4, right? So we got this is the point, what, 4, 2, I think, okay? And so we're going to revolve this region around. So if you want to picture it, right, it's kind of, it'll look something like that when you revolve, right? So what kind of slices do we have? Washer. We have empty space. We have empty space in here, right? Now again, not necessary for you to draw it. I think in the beginning it's helpful to draw it, okay? It's helpful to draw it to see those washers, whatnot, but you don't have to. So where's your, well, since it's a washer, so you might be tempted to draw a strip in here like that, but does that strip do you any good? Strip doesn't do you any good, right? What you want is the radius. The radius always has to come from the center, okay? So the outer radius is going to be there. Again, if I draw a washer in here, it's going to look like this. Right? That's going to be my washer. There's going to be my inner radius, and then there's going to be my outer radius over there. Okay? So, remember, radius, when you're doing circle or washer, the radius always comes from the center. Radius always comes from the center. And the center is always the axis of revolution. Wherever the axis of revolution is, that's the center, right? When you revolve around, the center is that axis of revolution. So the radius always has to come from here. Okay? So big R is the outer radius. That's a long one here. What's that going to be? This x coordinate is 4 minus 0. This radius is this x coordinate. What is this x coordinate? We're going to have to square both sides of this and turn that equation into that. So y equals square root of x turns into x equals y squared. So all that work we did with areas and horizontal strips earlier, right, pays off. So this x coordinate is y squared minus this x coordinate, which is 0. So then we get our formula, which is right here, pi. We factored out pi. If you guys weren't here that day, we did pi big R squared minus pi little r squared, outer circle minus inner circle. All we got to do is factor out a pi then. You don't have to factor it out, but it just kind of makes it a little easier. Pi, and then it'd be big R squared minus little r squared, of course, which is y to the 4th. And then that's from what to what? 0 to 2. The strips fill the space from 0 down here up to 2. 0 to 2. Okay? It doesn't take long, but you do have to spend a little time on these circle washer ones, the empty space, getting the radius drawn in the right spot. But once you get that figured out, just easy to set up, I think. Okay, what else? Any others? Okay, let's take a look at those things I handed back to you Let's go to the 2014 packet, number 2. Remember, we skipped some stuff here. So let's finish this out. Let's finish out what we can in this packet, which is a lot of it. Okay, we did part C, but we skipped the other parts. We skipped part A and B. All right. Here would be, okay, so region R is the base, part A. Find the volume of the solid generated when R is rotated about the horizontal line, y equals -2. So here would be y equals -2 down here. This is y equals 4 up here. We're going to take this region and we're going to revolve it around there. We're going to revolve it around y equals -2. Okay, do that. Do part A. And then you can go down to part B as soon as you're ready. All right, where do those things intersect? I think we might have figured that out for part C already, right? 2.3, right? Hadn't we already calculated that? Okay. Anybody got an answer? What do you got?
98.868.
All right. So, again, there's empty space, right? We're revolving around y equals -2. So that means this region's going to revolve around here, right? This region's going to revolve around y equals -2, okay? And so you're going to have this empty space here. So big R, little r, right? From the center, they have to come from the axis of revolution. So your big R and little r have to come from here up to the outer edge and then to the inner edge. That's the key. Really, the key to the washer ones. The ones that don't have empty space, it seems pretty obvious where the radius is, where the strip is, because it's inside the region. But when there is empty space, then the strips are actually usually outside, or at least start outside the region. And so that's what is different about it. So big R, so top y value 4 minus -2, and here top y value is f of x minus -2, and then you can just type that in later. You can just, remember, you can just, for your setup, it's okay to just write f of x then, okay? So minus -2 becomes +2, and then pi, and then big R squared minus little r squared, okay? And there it is. Okay, let's just do part B quickly here together. Well, I say that, and then maybe these are ones we have more trouble with. We shouldn't really. It's pretty easy. You know, this part's really pretty much easier. The region is the base. Cross section's perpendicular to the x-axis. So that means vertical. And it's an isosceles right triangle with a leg in R. Oh, wait a minute. Oh, that is different, isn't it? Yeah, let's talk about this. That's not an equilateral triangle. It's an isosceles right triangle. Okay? With one leg in R. So that means, so like I said, for our quiz, I'm only going to give you those 5 slices that we talked about. But there could be others. Well, what do you have coming up off the page then? When they talk about a leg of an isosceles right triangle, isn't this a leg? And that the leg? Well, isn't that the base and the height of the triangle? So what's the area of that triangle? 1/2 leg squared, right? Base times height. 1/2 leg squared, right? So what you have coming off of here is this red strip is here. You have a length the exact same as that red strip, and then the diagonal right here would be the hypotenuse. So coming up off the page, you got a leg, and then the hypotenuse like that. Okay? So it's just 1/2 the strip squared, right? So you may have to think your way through it a little bit. So the strip here is simply going, let's just call it, we'll call it leg, I guess. So the leg is 4 minus f of x, top minus bottom. And so the area, what will go in the integral is simply a 1/2 and then the leg squared. 1/2, then the leg squared. Okay, and then that goes from 0 to 2.3 again. And then whatever you would get, we won't worry about that right now, but we would just type that in there and we would have. Okay, makes sense? So that's a good one. I guess when I read that, I was thinking equilateral, but that's isosceles, so that's different. So we wouldn't use the root 3 over 4. But so you may have to picture what's happening. Again, the key is what part of it is the strip. What part of it is the strip. Okay, let's go to the 2016. Go to the 2016 packet now, number 5. We skipped part B on this one. We skipped part B. Now this was really an interesting one. 2 years ago on the AP test, I remember reading online in the kind of the discussion group of calculus teachers, and they always talk a lot. What? It's an exciting group, and we, and there's a lot of discussion after the test was over about the questions. Hey, what'd you get for this one? Oh man, we never. And this was a little different. I mean, the ones we just got to do in the 2014 were very traditional problems, and it was amazing how many people messed this up. And to be honest, yeah, if you've just memorized how to do the problems, they every once in a while they start thinking, okay, how can we ask this question to see if they really get the concept of what's going on? So what you have here is a funnel, and they just say find the volume of this funnel, and they have an equation here for the radius. Okay? So what do you suppose you're going to do? I mean, is it really that simple? I mean, I think it really is that simple. In other words, what are we always trying to find? What are we always trying to write down when we put our strips in there? The radius. Well, what have they done? They've given it to us. They've given us the radius. Okay? Now, it's in terms of age, but that's okay because we can set up our equation for our volume just simply that. Look at the slices. What shape are they? Circles. We want our integral to add up all these slices from here to here, like so. Okay? So we're going to have, so if you put a 0 in for h, for example, you're going to have a radius of, so if you put a 0 in here for h, you're going to have 3/20. So you can see it's pretty small, radius of 3/20. All the way up here to 10 squared is 100, you're going to have 103/20. Now the radius is much bigger. So that's it. I mean, it's simply pi times your radius squared. Since they called it r, you can actually just put r, but it's going to be dh. And then it's going to go from 0 to 10, right? So you can put into your calculator then pi, and or this might be a no calculator one. So let's talk about that real quick. I think this is a no calculator one. Oops, not 0 to pi, 0 to 10. So this would be this thing squared. So that would be 3 plus h squared. And the 1/20th I can just bring out here. So what's 1/20th squared? 1/400. Okay, and then this would be this thing squared. dh like that, which probably to be able to do it with an antiderivative, we probably need to FOIL that out. So we probably have a pi 400ths, and then we have 9 plus 6h squared plus h to the 4th dh from 0 to 10. And now we're going to take our antiderivative of that. The pi 400ths I could probably just leave out there. And then I would have 9h plus, raise it up to 3, divide by 3, that'd be 2h cubed, plus, and then 1/5 h to the 5th. From 0 to 10, and then we would put those numbers in. Okay, the 0 is going to be easy because that's just going to be 0. So it's just going to be what you get when you put in your 10. So you're going to have 900 plus 2,000, 10 cubed would be, 90, 90, not 900. 10 cubed is 1,000, so that's 2,000. And then 10 to the 5th, that would be 5 zeros. Over 5. What's that? 100,000 divided by 5 would be 20,000. That'd be 20,000. So 22,090 pi over 400. And they do not care if you simplify. I mean, we could knock off a 0 there easily enough. But they actually don't care if you simplify it. Right? But it really would throw people off. This really threw a lot of people off on this problem because they're used to drawing a graph, having an equation, putting in a strip, calling that the radius, the kind of the traditional way of doing it. But really, again, all you're doing is you're adding up these slices. You want your integral to add up the slices, and that's going to be pi r squared from 0 to 10. And they already gave you all. They just gave it to you. So, anyway. So that's an interesting one. Okay, last thing we want to do here, Let's go to sample 3. The sample 3 packet I gave you back. And let's number 20 we still can't do. That would be the last one we'll be able to do. But let's go to number 26. And I'll give you a little time to try this one now. This was a no calculator one. 26 should be no calculator. So being able to draw a little bit of a graph. Okay, does anybody have the integral set up? Pi 8s, 0 to 4,
Negative 1/2 plus 2 squared.
negative 1/2
Plus 2
x
plus x
plus 2
squared.
squared. Agree with that? I mean, because that equation, 2y plus x equals 4, you would have to solve that for y. Divide by 2, you get negative 1/2 x plus 2, so that's your graph, right? So if you hadn't gotten that far, that's the first thing you got to do. You got to do that, you got to grab it. right? Now, after that, there's going to be a bunch of algebra, okay? There is a bunch of algebra on this one. You're going to, just like we did on the last one, so I'm not going to spend a lot of time going all the way through it, okay? But it's going to be, you're going to have negative 1/2 x squared. Well, this right here, you're going to have to FOIL that, right? You're going to have to FOIL that. So the first one squared would be 1/4 x to the x squared. Your inner product, right? When you multiply those, you're going to have two of those. That'd be negative 1x, so that'd be negative 2x, and then plus 4. So that inside there is going to be like that. Then you're going to have to do the antiderivative of that. And then you're going to have to plug in your 4 and your 0 and all those things. So you got to keep all that in mind. So if you look at what I did here in order, over here I did the graph. Then I drew it, okay, negative 1/2 x plus 2 has a y-intercept 2, down 1 over 2, down 1 over 2. Got to be able to do that. Draw this. Here's my semicircle, right? Here's my little semicircle in there. But basically that strip, the key part I want to make sure we understand, the strip is a diameter. The strip is a diameter. So D would be negative 1/2 x plus 2, take away 0, top minus bottom. That's the diameter. Okay? So Harish was exactly right. Here's your setup. Now the rest of it's all algebra. I did my FOIL, then I did my antiderivative, now I plug in my 4, luckily those 16s all dropped out, blah, 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 here, cancel, cancel, reduce, 2 pi thirds. Okay? So a lot of algebra, but the key parts to understand is getting that integral set up, right? Getting that integral set up. If you can do that, that's most of the battle, although I guess it still doesn't matter if you can't do the algebra, you're not going to get that right answer. Okay, one more, but this one's a calculator one, so this is an easy one. Number 30, okay. Number 30 here. Now, I've already graphed it and looked at it here earlier today, and it's kind of graphed that kind of goes like this. And then x equals pi, so it says in the first quadrant, enclosed by the x-axis, the line x equals pi, and the curve cosine of x. Well, I went ahead and graphed it and everything, and here it is. Looks something like that. Now we're going to revolve it about the x-axis. So here we got no empty space, so this is pretty straightforward. You got your strip right here. What is that strip in this problem? What's that strip represent? Radius, right? Here would be your slice right here, right? Here would be your slice. You revolve that region. It's simply your radius. Well, that's just cosine x minus 0. And so your integral is pi radius squared from 0 to pi, because this was the line x equals pi right here. So pretty straightforward one there, right? That note calculator one took a lot more time. Now, if you were doing this one, you'd have to graph it first. You get up and look at the picture just to make sure, where it was at and everything. But and now you just put that in your calculator and find your answer. Okay? All right. So that's a little bit of work on those and where we can have kind of seen those in our package. So one more day of assignments with that. Just a few of them here. There's a few that have multiple parts again. But let's do that for tomorrow's homework. You could work the rest of the time for that. We're gonna plan is tomorrow to be working to go over some of this a little bit and maybe see if you have any questions in the 2017 packet at all. And then probably work time on a new packet. And then Wednesday we'll go into the other volume method. So if you do need to leave a little earlier tomorrow for the funeral, probably not, but if you happen to then. we'd be doing some work time towards the end. Yes.
You can answer what time.
Traditionally, for that meet, it's ridiculously early.
You gotta go to fellas.
Right. It's 10, 9:30, 10, 9:45, 10, something like that. Right. Kind of like the soccer team leaving at noon when they played at 4 the next day. A little bit the same.
We were supposed to play.
I know, it was all up in the air. You weren't sure when you were going to play. Yeah. Right. No, I get it, but
We played one game.
and then you played one game. Yeah.
Yeah, we were supposed to play two, but they did it. There's only 6 teams there, so the steering's got what income. So the first, second seed,
You guys got to buy.
It makes it so much easier once you drop it.
But then they were going to play the championship, but did it just get too cold, they thought, or too late, or what?
You can't play this with 1, 2,
North Platte?
3, 7, 6.
3 and 6 and 4 and 5, right?
So like, if either of these teams beat us or them, this was the North Platte, and they won, so they already played 2 games.
You can only play 2 games in a day. So
Oh,
if
that's
we won
why.
The championship game
So
would
if
have been
Columbus
the
would
third
won
game.
and we would won, we would play the championship.
I got you.
So now we play today.
But North Platte beat them in PK, so.
So you guys did you guys have to wait around for that game?
We won to go home.
We have to go home.
So did you guys wait around for that game?
No, it was the same time.
It was the same time you were, okay. So at least you'd have to wait around
Like,
for
we
2
did
hours.
We were like, yeah, and then we saw North Platte won, we were like, yeah, we go.
Yeah.
We can go home now, yeah, we have to. Yeah, go
I think
ahead.
the girls were more happy they didn't. I mean, I was happy because we gotta go home. But like the girls were definitely to stay for another game.
Oh, they did stay.
They would have if we would have if Columbus would won.
Oh, because they had to stay to watch it.
Yeah.
Yeah, that's a good point. So did the girls win?
No, they lost. They
Oh.
lost the shootout to Hastings.
Okay. Who was what, like the 4 or something, probably?
What?
Must have been the number 4 or 5?
Yeah, 4.
Because we were the 1, right?
Yeah.
Okay.